Hi everyone, my name is Sandeep. I'm the principal architect at Aarna Networks. So I'm going to talk about the Nephio R2, and my talk might be more focused on the SIG automation group. So what are the features in the Nephio R2? So if any of you is familiar with Nephio R1, you will recall that in Nephio R1 we could orchestrate the free 5GC. Now Nephio R2 brings in the multi-vendor support, and that is shown by orchestrating the OAI free 5GC plus OAI core and OAI RAN. OAI is open source community, and OAI has all the core network functions, containerized network functions, and the three RAN related network functions. Plus, OAI also has the simulators, the UE simulator using which you can pretty much test the end-to-end deployment. And all this has been automated in the Nephio R2. And then Nephio R2 also brings in the topology controller, which is in experimental phase at present. So what topology controller would enable the users is to specify the intent at the topology level. So this will be the CR using which you could specify the overall network topology, the network functions that are to be deployed in the data path or control path, plus the properties of those network functions. For example, if it is a UPF, you might specify that my UPF requires a special kind of hardware, and my UPF requires a special kind of location, special edge. Plus, of course, the kind of networks these network functions require. So all this information will be specified as a custom resource of the topology controller, and that is the high level intent. And then what else? Installer is another. Actually, installer was there in R1 as well, but I mean it has been enhanced. So now there is a single command that you can run on your system, and you can pretty much create the end-to-end system. And it is very easy to try out Nephio, and there are very well written, well documented user guides, both for the free 5GC and the OAI, which you can try. And I recommend that you should try, because that gives a lot of clarity about the mission of the Nephio. And basically you will understand the whole notion of the intents and intent driven automation, how the overall configuration that is required in order to deploy the network functions is generated and created dynamically, which is the magic of Nephio. And the end-to-end test suite. So this, I mean, if you try out the installer and the end-to-end test suite, so that is how basically you will end up running the OAI deployment. So I have given links for all the Git repos in my last slide. And documentation was a gap in R1, which has seen a lot of improvement now. So there is good documentation, and I have also provided a link to the documentation. So the main feature is the OAI 5G core and RAN automation. And OAI has the network functions for all the 5G core, and all these are containerized network functions. And OAI also has the RAN related network functions, namely the DU, CUCP, CUUP, plus the simulator that I talked about. And these are the network functions that are deployed as part of the OAI deployment when we install OAI using the Nephio R2. So what has Nephio, or what has the community developed for the automation? So primarily, so the flow starts with the operators. So first thing that is developed is the operators for both the core and the RAN. So RAN operator is developed using an SDK. So this basically will give you an idea about how anybody can create operators for their network functions using the SDK, which is which is experimental at this phase, but this is a proof of concept. So there is one operator created for the RAN, and the same operator is deploying. The same operator deploys the all the three RAN network functions, and then there are operators for all of the 5G core components. And these operators are written in Python using the KOPF framework. So as the slide says, the green ones, which are the RAN related, they are written in Go, and they are present in the Nephio repo. I have provided the link for this in my last slide. And the pink or orange, pink one is are the Python-based KOPF based operators. So these operators, so what do they do? So these operators basically create all your deployment.yamls, your config maps, service account.yamls, basically whatever is required in order to deploy these network functions. So now going one layer above, uh, what are these? I mean, what is the interface or what is the API for these for these operators that I talked about? So there are two CRDs that are defined in the R2. So one is called the network NF deployment. So this is the same CRD, or the CRs of this CRD are what are reconciled by all the operators that I talked about in my previous slide. And that is how, I mean, we can standardize the development of the CRDs for network functions from different vendors or different organizations. And then the other main CRD is the NF config. So NF deployment has the information that is required to basically create the deployment.yaml of different network functions, be it AMF or be it the CUCP. And cnconfig spec defines the configuration that is required in order to create an AMF or in order to create CUCP or the UPF. Plus, there are other config related CRDs which are called config that contain information about the dependent configuration. For example, the RAN basically needs to know the interface information of the AMFs, for example. So when we create the bundle for the deployment of the RAN, and that bundle basically has the NF deployment CR, the NF config CR, plus the supporting config CRs. So they will contain information which is which is basically reconciled by these controllers, and they create the deployment.yamls, consume the configurations, resolve the dependencies with the AMF N2, N1, N2 kind of interfaces. So these are the, so first layer was the operators. First layer was the network function itself, then the operators for those network functions. Then above that are these CRDs. So this slide, I think there are subsequent presentations which might touch upon the details about the orchestration, but I'll talk about, I'll summarize the end-to-end flow of the automation. So the automation starts with a package variant object, which is an object of the porch. So there is detailed presentation on porch, I think next presentation. So porch basically gives you a Kubernetes interface to Git. So using porch, you can basically pull packages, mutate them, hydrate them, and push them back to the target repos to which the target clusters are reconciling to. And Porch has this object package variant where you specify your upstream repo, your downstream repo. And in the upstream repo, you have the base package. For example, your base package of AMF could have a very basic NF deployment spec, which has to be generated and created dynamically. And it will have almost empty config specs, which are to be populated by the informations like the network attachment, information that is required to create a network attachment, for example. And then Porch basically will pull this upstream repo, create a package variant, create a package revision, which is an object for the downstream repo. And then this package revision is worked upon by all the controllers and different functions which are generating the configuration that is required to create the complete NF deployment, NF config CRs dynamically. And this happens over, this happens over a pipeline. Basically, all these controllers which are responsible for maybe getting a VLAN or getting or interfacing with the IPAM, for example, generating the network interface definitions. So these are all the backend controllers. They are basically synchronizing on this pipeline. And every controller is taking its work from this pipeline, doing its job and setting certain conditions true. And that's how the whole synchronization happens. Eventually, this whole pipeline will succeed, everything will become true. And the result of that will be a populated network deployment and network config CRs. And then those CRs are basically approved by a controller, which is called the approval controller. So in ports, right? Ports has in ports the packages have a life cycle, and only the approved packages are the ones which are consumed by or which are synced by the config sync. Config sync is basically your Git sync, which is sitting in the target clusters, and that is continuously syncing the configurations in its repo. And Porch's job is, and Porch combined with all these controllers, so their job is to pull base packages or golden templates, mutate them, hydrate them based on the requirement of that network function and based on the environment of the target cluster, right? I mean, what kind of network exists in the target cluster. So all that automation, all that magic happens here. And then the mutated package is pushed into the target repo, and a controller is continuously watching this pipeline that is called the approval controller. So this controller is basically, it sees when all the conditions are met, it will auto approve that package. And once it is auto approved, the config sync is going to pull it. And that's how your network functions will get deployed, because that pull of the config sync will create the NF deployment custom resource. And then in your target cluster, you have the NF, you have the operators that I talked about, the RAN and core operators, which are reconciling on this NF deployment object. And that's how all your network functions will get deployed. Yeah, there is a lot of detail into it. I could, for my, I mean, the time slot and the number of slides, I just gave you an idea. I recommend that you try this out, and yeah, this will help you understand. So these are the references. So I have put a link to the user guide. So this user guide has, I mean, it is for OAI and for Free5GC both. You can browse through it. And then there is a recorded demo, which is basically created by following this user guide. This will help you, I mean, create a demo on your own if you want. And then GitHub pointers to the OAI operators, both RAN and core. Yeah. Yeah, so that's all I have.
Now, this slide's context, how do you get this intent? Where do you take that intent in this slide?
So intent is even above this.
Is it super high, or can you locate it or get it somewhere closer to this picture? It will be helpful. I mean,
So intent would be the topology controller CR, which is not in this diagram. But imagine that there is a topology controller and there is a CR, there is a custom resource that you created in which you specify that the spec says that you want to deploy a network function, and the kind is AMF, and it is from this openair interface.org. And then you also say that you want to deploy a RAN. So that's how you basically create the spec of the topology controller. Now, topology controller, as part of its reconciliation, will create these objects, these package variant
my
objects.
question is, would there be, or trying to understand, would there be lower intents? I get that higher view, but would there be a cascading down or a percolation down, and there would be definitions at the lower levels as well, maybe at this level, just to visualize? Would there be, or?
So by lower level, what do you mean? At the core configuration level of the network function?
Yes.
So that
Do you envisage?
I doubt that it will be in scope of the topology controller. So it is meant for high level intent, and the details of how to generate the configurations specific to network functions. So that is the crux of the automation. I mean, the business logic of the automation, the supporting KRM functions and controllers should know how to generate the configurations of the.
You mean basically they should be able to translate?
They should, yes. That's what happens in the OAI pipeline. It knows how to generate. you want to add?
Thank you.
And maybe the way to look at it is this is the scope of topology controller. The next level of bottom intent is what Kubernetes will specify, right? If you are looking at, let's say, edge cloud CRDs and so forth. So there's a clear distinction between what Nephio is building and what the underlying Kubernetes capabilities will look like.
Exactly. So
Right.
my point was the user in Nephio is mostly specifying the business intent, the high level intent, and the lower level intent should be driven automatically,
Yeah, thank
which
you.
are specific to, like Kaushik said.
OAI operator, right? Were they already there?
No.
Okay.
So OAI operators are, so these operators are what are written in R3.
Okay, so both of them for the core as well as for the RAN.
So RAN, there is one operator which is basically creating all three network functions. It is more of a reference because it is a step towards the SDK. I mean, the SDK for creating these operators. So look at it more as a reference architecture or a reference for creating operators for your, I mean, if you have any network functions. And core ones are Python-based, KOPF-based operators. Yeah, so they were written. Maybe the implementation might have started before R3, but the whole definition of this NF deployment CRD, so all that happened in R3. So that is.
Thank you.
Nephio operator SDK, are you going to add some additional functionality than the base Kubernetes operator SDK, or you're taking that as a plain, using it as it is for Nephio context?
No, it will have functionality which is required to create operators, I mean, specific to or which can work in
The Nephio construct.
Yeah. At present, it's experimental, it's basic, but that is the plan.
Okay.
Thank you.